our university. And today I am going to present a presentation on estimation of thermal conductivity of unknown matters. This was done in my master's as a master project, and this is the outline. Please next. This is the outline of this presentation. The outline is first we'll talk about the thermal conductivity, then we'll see what are the application of thermal conductivity, and last experimental setup, different stages of experiment and resulting conclusion. So first of all, thermal conductivity. Thermal conductivity is the parameter which can help you to understand a matter ability of conduct heat. Right? If thermal conductivity is good, then matter can be transmit more heat through the matter. So it can be denoted as a K, and unit is watt per meter per calorie. So now, how you can measure the thermal conductivity of any matter? So there are two different methods. One is the steady state method, and another one is the transient method. In steady state method, you are supplying constant heat, and you are applying the formula of Fourier law. Where in transient method, you are going to apply a spark of heat, or maybe you can say heat wave, or you are applying a frequency, and you are measuring how the material is changing the temperature, right? And you are applying the heat diffusion equation in case of transient heat. Now today in this experiment, I have used the steady state method. Next, please. Okay, so these are the application. That was the application, and the experimental setup is just like this. This is the where you can see here is the heat insulation I have used as a thermocouple. Then at the upmost side I have the oven for the heat source. At the downside I have cold sink, or you can say heat sink, and in between the hot and cold part I have the metal sample as a rod, cylindrical rod, where the diameter of rod is 1 centimeter and the length is nearly 30 centimeter. For measuring temperature, I have used the thermocouples. So in this experimental setup, each and every part which I have used, these basic elements. There is no any fancy setup, or you can say which is available in market. So now there are different stages of my experiment. First, if I am using thermocouple, then it should be calibrated with your traditional or mercury thermometer. Then second stage, determine the heat flow, and the third stage is determine the value of thermal conductivity of different matter. So in the first part, to calibrate thermocouple, the simple set I used in beaker, I have used the water, and place there are 5 thermocouples with digital temperature meter and the mercury thermometer, and I have applied room temperature to the 100 degrees Celsius. Then my data was plotted in the graph, and this graph shows me that the temperature is linearly increased with the thermometer and thermocouple. The fitting curve is R square is near equal. You can see the R square table, it is near equal. It shows me the dependent and independent variables are very muchly fit, or you can say closely perfect fit set I have used. So now my thermocouples are calibrated. So the next part is, let's go on the sample and measure the thermal conductivity of sample. So the formula is Q is equals to minus Ka dt by dx, where Q is the rate of change of heat, K is thermal conductivity, your A is the area of sample, and dt by dx is the temperature gradient over distance. So in my experiment I have used first brass sample and taken the ideal thermal conductivity value which is available on different research paper, and ideal value which is 109 watt per meter per calorie. Area I know of my sample, it is easily calculated by pi r square. So I know the area, I know the thermal conductivity, I have measured the temperature gradient with thermocouples which is situated at 5 centimeter distances, and with this I can easily identify the Q. Now my Q value is nearly 2.91 watt. So the first of all, if I am using only one sample and I am measuring the Q value is this 2.91 watt, so I should apply the next sample and check whether it is correct or not. So same perform I did. I used aluminium material. Please next. I used the aluminium So that value is ideal for me for my setup, and I use the unknown material for my experiment. I have used mild scale MS as an unknown matter. Now with the MS, if I perform the activity, same activity, like I know the area, I know the temperature gradient, if I know the Q, which is just calculated as 2.9, this is the thermal conductivity of MS, mild scale. And the thermal conductivity which I have calculated, that is nearly 58.17 watt per meter per Kelvin. And if you see the ideal data available in different research paper and some websites, so it's close enough to 51.5 watt per meter per Kelvin. So it is close enough, you can say. Now, different setups are already available in the market, but the cost of setups are nearly or above 50,000. Where I have used very scrappy materials which is available in our daily life or in our normal laboratory. I use the thermocouple, which is very cheaper, like 50 rupees somewhere around. Then I use the thermocol, which is available in always in our laboratory in the different chemical bottles. And the heat source which I have used, that is the one of the experimental setup available in our laboratory, that is 4-prong method. So you can say that each and every elements are available. So it is very cost effective process and very learning process for higher secondary students or else the undergraduation students. So what are the disadvantages and advantage of my method? So disadvantage is the time taking is very much high. In case of steady state, if you are using, so the time taking process is high, and the temperature sensor errors you cannot eliminate, or else the heat source error you cannot eliminate. So there are always some source of error in your experiment. And the advantage is it is cost effective, very widely utilized, or you can use everywhere, and also it is reliable. The main part of my research is with this technique you can give the idea of undergraduation students or your normal high secondary students. They can also calculate thermal conductivity in their laboratory, or you can say experiment lab. So this is my goal. Thank you. Is there any question?
Are there any questions?
Okay. Thank you so much.